Welcome to HB Tuner's Ford Gen 2 Coyote Training Part 18. This training module we're going to be taking a look at dialing in our mass airflow sensor and doing a demonstration from start to finish of dialing in idle, part throttle, and even some wide open throttle using our fuel trim data, populate it into a histogram that we can go in and then bring into our calibration file to update. So this process is relatively straightforward. We're going to be showing you everything from start to finish. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at how to dial in our mass airflow calibration curve using our VCM scanner and logged data. Now, the last tutorial we went over prepping our calibration file, so we were in a MAF only mode. We want to be able to dial things in for the mass airflow calibration curve without the influence of filters or speed density. We're going to find out how it's going to run here when we fire off the engine, and then we'll move into the VCM scanner and we'll talk about a few things before we actually fire off the engine, just to get a little bit more familiar with what we need to have open. And so you can follow along on your vehicle if you want to go and dial things in. Pretty straightforward process here, but again, there are some things we need to know that are very specific. So let's jump in here and take a look. The calibration file that I am working with here, I have renamed. It's called MAF Tuning. It's the exact same calibration file that we went over in the MAF Basics tutorial, so nothing has been changed. I flashed it to the car off camera. I'm ready to fire off the engine now, so that's where I'm at. Let's just briefly go over the changes that I made in that previous tutorial so we can kind of get a point of reference where we're at right now before we fire off the motor. So under engine here, if we go into airflow and then into general, if we move across here under MAF calibration, we've went in here and we've went to the MAF adaption, and that's set to disabled. That gets rid of any learned behavior working with the mass airflow sensor. The cylinder air filter has been disabled. We may run into problems with this. This turns off the filtering function on the MAF sensor, so it's giving a raw signal into the engine control module. Sometimes this is a problem. We'll know when we fire it off. If it runs very poor, then we'll turn it back on again. We might have to just dial things in with a filtered MAF signal, not a big deal. Then we have our cylinder air anticipation. By disabling this function, it turns off the speed density influencing in a transient type of environment. So if we have a large throttle change or airflow burst, this makes sure that the speed density calculations aren't weighing in on any air mass determination. So it's just solely on the mass airflow sensor. There's a cylinder air watt multiplier and max multiplier. These have been raised up so that we don't hit a clip in reporting our engine load from our mass airflow sensor. So we've raised up to 1.99. That's the highest they can go. For right now, we can leave those there. Now we have went into the mass airflow versus frequency curve, and I copied and pasted the data for a JLT carbon intake. Now this isn't the exact intake I have on this particular engine here. This intake is a JLT GT350 intake assembly, so it is not the same, and we're going to have to go and dial this MAF curve in, which we're going to take a look at how to do that. I have at least something that's close to start. The best thing would have been here is to measure the stock airbox assembly at the mass airflow housing, measure the JLT intake at the inner diameter of the mass airflow housing, and then use the Excel spreadsheet calculator that I introduced into that last tutorial to be able to figure out a rescaled curve that will get me really, really close. In this case, I don't have that luxury because I don't have the stock airbox assembly from this vehicle. When I purchased the vehicle, it had a different aftermarket intake on it, so I wasn't able to confirm the inner diameter of our stock airbox assembly. No big deal. We can figure this out through logging through the VCM scanner, which we're going to talk about here in just a little bit. But I wanted to go and point out that I have used the values here from this JLT carbon calibration curve. So let's jump back in here. So we've prepped our mass airflow curve to begin. Ideally, we'd like to have the mass airflow curve coming from data, let's say from a manufacturer, supplied to us already, so we can copy and paste it in. It's best to always start off like that, but chances are you're going to be in a situation where you switch out your intake and you're not going to have the data available, and even going in and figuring out stock inner diameter, aftermarket inner diameter using Excel spreadsheet, there's still a margin of error there. So we're going to have to clean that up. That's what we're going to be looking at here, how to do in this tutorial, how to recalibrate the MAF curve if things aren't exactly perfect, which they're most likely not in this situation. Now, I do have the luxury at this point in time having stock injectors in my fuel system. So I have the stock injectors. I know all the injector data from Ford's good. So if I'm finding that looking at our closed loop operation, and we've talked about closed loop, what that means and what it represents using the front oxygen sensors, if I'm finding that there's a large short-term deviation, so we're adding a bunch of fuel or taking some fuel away, that means that the air the reason why we're richer or leaner than the target is due to the intake calibration or the MAF calibration being off because our injector data is stuck. You might get into a situation where you've changed your injectors and you change your air intake assembly at the same time. In that situation, you could have an error, so richer or leaner than your target, coming from your fuel modeling side, meaning when you convert fuel mass into an injector pulse width through the injector data. Something in the injector data could be wrong. Your low and high slope value could be wrong. Your offsets could be wrong. Something could be incorrect there, leading to an error in your fueling. Or you also might have the situation where I'm in right now, where I'm probably going to find that I'm off on my air intake assembly here in terms of the mass airflow calibration. You could actually have two happening at one time. In this case, I've stripped out the ability for the injectors to become a problem, and now we're looking at just the mass airflow calibration process.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.